so what we'd like to start with here is I'm gonna start you guys with a number here. It's gonna be 16 over 3. And I want you to tell me what categories it belongs to. All right, so is this a natural number? We cannot get if I take 16 and divide it by 3, it doesn't come out to a whole number or a natural number. Right? Because 3 times 5 is 15, and then we kind of have a third left. So it's not a natural number. And if I add a 0 to it, it's not a whole number either. Then the next step is integer. Is it natural, the opposite of natural, or 0? No, so it can't be an integer either. Now, is it the ratio of two integers? In this, it is. It is 16 over 3, the ratio of two integers. So it is, in fact, a rational number. And because it's rational, it cannot be irrational. And because it's rational, it has to be real. So rational and real. Very good. All right, let's do 1/4 plus, let's do 3/5. Add those two fractions together. 1/4 plus 3/5. Good. All right. So here I would need to find a common denominator. So in this case, I'm looking at now one thing we have to do here that I kind of want to explain. So when you're dealing with fractions, we always multiply these fractions by the number 1. So if I did 1/4 times 1, I would just get 1/4. And if I did 3/5 times 1, I would just get 3/5. So you'll notice how there's no difference. I haven't changed anything by multiplying each individual term here by the number 1. That's going to be very important here in a second as I kind of explain what's going on here. Now, the other concept that we want to use is anytime I take a number, let's say 17, and I divide it by 17, if I divide a number by itself, that answer is 1. Okay, it doesn't matter what the number is. It could be 6, 12, 17, 58, 6,000, negative 40.5. As long as it's the same thing over itself, dividing it will always result in a 1. So we're going to leverage these two ideas, multiplying by 1 returns the same thing, and the fact that I can express the number 1 as the ratio of two identical integers. I'm going to use that to re-represent these two fractions. Now, we talked about expressions before. So if I were to express the number 10 to you, I could express it this way. I could also express it as 8 plus 2. They mean the exact same thing. I've just simply expressed it differently. And sometimes expressing it differently helps us do math. So in this case, if I find a common denominator between 4 and 5, that's always going to be the least common multiple. So 4, 8, 12, 16, 20, 5, 10, 15, 20. 20 is the least common multiple. So what I'm going to do is I'm going to take this 1/4 and I'm going to take this 3/5 and I'm going to multiply the 1/4 by 5 over 5. So you notice that that's the same thing as multiplying it by 1, just like here. Any number over itself is 1. I've essentially multiplied this by 1. The number will change. 1 times 5 is 5. 4 times 5 is 20. So the number looks like it changed, but it actually didn't. 5/20ths is the same thing as 1/4. And we're going to do the same thing here. 3/5 times 4 over 4. Why 4 over 4? Because I'm trying to get 20, the least common multiple in the denominator. So when I do that, 3 times 4 is 12, 5 times 4 is 20. Now I have the common denominator. 12 over 20 is the same thing as 3 over 5. It's just represented differently. Okay, because all I did was multiply it by the number 1, but I'm showing 1 as 4 over 4. So I haven't actually changed anything. This is still 1/4 plus 3/5. But since I'm now representing it with a common denominator, now the top simply becomes 5 plus 12 because they share that common denominator. And that's where we get the answer 17 over 20. Okay. All right. All right. Let's do 4/3 divided by -3. 4/3 divided by -3. All right, so here we have a number divided by a fraction divided by a whole number. Now, in order to explain how to do this, I always try to use this example because I think it helps communicate dividing with fractions. All right, so if I have the normal number 8 and I divide that by half, okay, think about having 8 apples, right? And I said, divide those into halves. And you came and you divided each one into halves. Well, how many halves do you have? Well, you have 1, 2, 3, 4, 5, 6, 7, 8. You have 16 halves, right? So we know that physically, if I gave you 8 apples and told you to divide by halves, you could see where we get the number 16. But mathematically, how do we do that? So if I have the number 8 divided by a half, what I have is I am multiplying by the reciprocal or the inverse of 1 over 2. So 1 over 2, the reciprocal of that would be 2 over 1. Okay. Now, the other principle that needs to be understood as we go through this is that any integer, in this case, we'll be doing this with -3, but any integer, let's say 7, can be represented as a fraction of the same number over the number 1. So 7 over 1 is the same thing as 7 divided by 1, which is just 7. So we can represent 7 as a fraction as 7 over 1. Okay. And the reason I say that is I want to represent this 8 as a fraction. So 8 divided by 1, 8 over 1. Because now I have two fractions and it's easy to see how I can solve that. Okay. If I have 8 over 1 times 2 over 1, I can multiply across the top. That gives me 16. And then I can multiply across the bottom. 1 times 1, that gives me 1. 16 divided by 1, obviously, is just 16. So that's kind of the nature. Multiplying by the reciprocal is the same thing as dividing by the number. And this works in regular division as well. You can transform any division into multiplication. So for example, if I did 4 divided by 2, well, you know that that's 2, but that's the same thing as 4 over 1 times the number 2. The reciprocal of 2 would be 1/2. So now you'd have, we're not really gaining anything because 4 times 1 is 4, 1 times 2 is 2. You're right back to this. But you can see how this division is the same thing as multiplying two fractions. All right, so then how does that help us here with 4/3 divided by -3? So let me jump in here and rewrite this. Okay, so 4/3 divided by -3. The first thing I want to do is turn that -3 into a fraction. So 4/3 divided by -3 over the number 1. Okay, that's turning that into a fraction. Next, if I have a fraction divided by a fraction, I know that's my top number multiplied by the inverse of the bottom number. Okay, which is 4/3 times 1 over -3. So if I multiply across the top, that gives me 4. And then if I multiply across the bottom, that gives me -3. 9. Now, before I say what my final answer is, I want to review another concept with you, and that is the number 4 over negative 9 is the same thing as the number negative 4 over 9, which is also the same thing as negative 4 over 9. So these three ways, and this is nomenclature, this is just kind of the language of mathematics, this needs to be understood. Okay, 4 over negative 9 is the same thing as negative 4 over 9, which is the same thing as negative 4 over 9. And this is one of the biggest mistakes that I see students make in calculating fractions because they forget about the negative or they get confused depending on where the negative is at. Don't get confused. Know that all of this represents the same thing. Most of the time, you're going to see expressed like this. But every once in a while, like here, when you're working things out and that negative is attached to a 3, you end up with a negative here on the bottom. Then the very next thing that you write is negative 4 over 9. Okay, and that's the same thing. And if the negative happened to be on top, like it would be here, you're still writing this as your final answer. All right. All right, I'm going to give you another problem here. X squared plus y minus a. X is 4, y is 3, a is 2. All right. So if I plug in the 4 for x, this becomes 4 squared plus, if I plug in the 3 for y, that gives me 3 here, minus, and then if I plug in the 2 for a, that's minus 2. All right, so 4 squared would be 16 plus 3 minus 2. 16 plus 3 would be 19 minus 2. 19 minus 2 would be 17. All righty. All right, so now from what we talked about last time, I'm going to give you the absolute value of y minus 12 is equal to 3. What is y? All right, let's look at this. All right, whatever the number ends up being in here, that has to either be negative 3 or 3, because the absolute value of both of these gives me 3. So that means that y minus 12 must equal negative 3, or y minus 12 must equal 3. So now that we know that, we can solve for what y has to be. Okay, so I'll do the one down here first. What number minus 12 gives me 3? Well, that number would be 15. The other thing we could do is just simply add 12 to both sides. 12 plus 3 gives me 15. Easy enough. Here, y minus 12 is equal to negative 3. So you think, okay, what do I have to have here for y to when I subtract 12, I go all the way down to negative 3? So you could look at a number line and think, okay, if this is negative 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. You could say, okay, if I land at negative 3, if that's my answer, okay. And whatever number I started at, I subtracted 12 to get here. So let's see what would be 12 up the road to where I subtract 12 and I land at negative 3. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's 9. Positive 9 minus 12 gives me negative 3. So y can be positive 9. Now, the other way algebraically that I can work that out is if I add the number 12 to both sides, negative 12 plus 12 here leaves me with y. Negative 3 plus 12 is positive 9. So here we have y is equal to, and we'll use the squirrely brackets here, 9 comma 15. All right, good job. What does x have to be for this to be true? X over 4 is 4. Tell me what x has to be. What does x have to be for that to be true? So the number here would be 16. 16. Now, what I could do to solve this is I can multiply both sides, excuse me, by 4. So this 4 is 4 over 1, 4 on top and bottom, there, cancel. I'm left with x. X is equal to 16, right? This would left with x over 1, because 4 over 4 is just 1. X times 1 is x. X is equal to 16. All right, what about this one? 5 is equal to 1 minus r. What is r? 5 is equal to 1 minus r. What is r? Be looking at this thinking, okay, that looks crazy. I don't know what I would subtract from 1 to get 5. I could do it the other way. If it was r minus 1, then r would just be 6, right? 6 minus 1. But that's not what we have. We have 1 minus r. So how do we get to 5? So if I don't know how to do this, remember, you can add and subtract whatever you want to both sides. So because you have a negative variable, sometimes that throws people. So you are allowed to add r to both sides, okay? Minus r plus r, that goes away, and you're left with 1. Okay, 5 plus r is now, the r is now on the other side, okay? And that's okay. I've added r to both sides. So even though it disappeared here, that's fine. I've added it to both sides. That's all I'm responsible for. Okay, you don't need to see the r on both sides. You just, if you're going to move it, you just have to add it or subtract it, whatever's going to move it. All right, so now I have 5 plus a number is 1. And you might be thinking, good Lord, I still don't know what that number could be, because if I'm adding to 5, why am I going down, right? So what we can do now is we can simply subtract 5 from both sides. 5 minus 5 is 0. 0 plus r is the identity, which just results in r. 1 minus 5 gives me negative 4. Oh, interesting. Negative 4. If I plug in negative 4, 1 minus negative 4, I see here that minus a negative, that's going to be a positive. So what I have here is 1 plus 4, and that gives me 5. That makes sense. So good work. All right. All right, so now what I'd like to do is work on something a little bit different. And that's going to be, let's look at, let's see. All right. Notice that I have now a variable in 2 locations instead of 1. So what do I do in these situations? All right. So if I have 8x minus 7x equal to 2, how do I take care of that? So let me double check my syllabus here real quick. I want to make sure I'm not going to mess up what we're doing. Okay. So it's a couple weeks before we will actually talk about this in particular, but I do want to at least explain part of it now. I'll explain it again in a couple of weeks. But we have here things that we are either adding or subtracting. When we have things in an equation or an expression that we add or subtract, those things are called terms. Okay. There are two terms on this left side of this equation. Okay. Those are called terms. When we multiply two things together, so if I multiply 3 times 5, and that equals 15, okay, 3 and the 5, things that I multiply or divide, those things are called factors. Terms and factors. Okay, you need to be writing this down if you're taking notes. And if you're not taking notes, you're going to start taking notes and you're going to write down terms and factors. What are terms? Things we add or subtract. And what are factors? Things we multiply or divide. Okay. And technically, and we'll cover this at the end of Algebra 1 or when we do Algebra 2, if you guys do the classes with me for Algebra 2. The technical term will actually be things that we add, because what we will realize is that we can all subtraction we can convert to addition. And the same thing with factors. Everything that we divide, we can actually convert to multiplication. So technically speaking, terms are things we add, factors are things we multiply. But for our sakes right now, we're going to say if we're adding or subtracting, it's a term. If we're multiplying or dividing, it's a factor. So here we are adding and we're subtracting the 8x and the 7x, so those are terms. All right. Now we can combine things that are called like terms. Okay. This is another thing that you need to write down. Like terms. Write that down on your paper. What are like terms? Like terms are the same variable and the same exponent. Same variable, same exponent. And why do we care if terms are like or not? Because if they are like terms, then we can combine them. And let me show you this. All right, so in this case, 8x minus 7x. I'm going to combine this. If I combine the 8 with the negative 7, 8 minus 7 becomes 1. So 8x minus 7x becomes 1x. And 1x is equal to 2. 1 times x is just 1. So x is equal to 2. All right, let's see if this works out. If I have 8x minus 7x and I plug in the number 2, 8 times the number 2 minus 7 times the number 2, does that in fact equal 2? All right. 8 times 2 is 16 minus 7 times 2 is 14. 16 minus 14 is 2. And yes, 2 is equal to 2. So we are good there. We can combine those. Now, let's say that instead I had 8x minus 7y equal to 2. Can I combine those? Well, no, because y is not the same number as x. Okay, if y were 3, for example, and I tried to combine this, I said, well, that's 1 xy, right? That's equal to 2. Well, if I already know from here that x is 2, then 2 times 3 is 6. That's not 2. This is not going to work. So I can only combine things that are the same number. All right, so terms and factors. So let me give you a practice problem like this. Let me find a good one for you. All right, let's do 3 times x plus 4 times x equals 21. All right, so here I can combine the 3 and the 4x. That gives me 7x is equal to 21. All right, and here I can divide both sides by 7. 7 over 7 is 1. 1 times x is x. 21 divided by 7 is 3. Remember, if you have any questions or if you want me to redo something, just message a question mark in and I will redo something for you. All right. Now I am going to do something a little different. Let's do negative 5x minus 9 is equal to 1 plus x. So you'll notice here, my numbers, my variables are on different sides. So you'll have to do something with that. So go ahead and work on that. While you guys are working on that, let me kind of revisit this idea here. So these are like terms, 3x plus 4x. So I can combine that into 7x, and that's going to equal 21. Then this x right here, what does it have to be in order to be 21? So you can kind of see from right there that that's going to be 3, right? 7 times 3 is 21. But the other way that I can get there is if I divide this by 7 and this by 7, okay? 7 over 7 is 1. 21 over 7 is 3. 1 times x is just x. X over 3. Or x is 3. There you go. All right. So let's look at this one here. Negative 5x minus 9 is equal to 1 plus x. What on earth do I do with this? Okay. So what I want to do is I want to get x by itself, either on the right side or on the left side. Because if you remember from your transitive property of equality, I can switch sides on if something's equal to something and everything remains the same. So it doesn't matter which side the x ends up being on. So here what I'm going to do is I'm going to go ahead and add 9 to both sides. Okay. So I have negative 5x minus 9 plus 9. So that's going to leave me with negative 5x plus 0. I'm going to go ahead and leave the plus 0 there. I know some of you can already skip that step, but I think it'll help people that are still kind of struggling. And then 1 plus 9 is 10, and then plus x. All right, so the plus 0 will just leave me with that. So I have minus 5x is equal to 10 plus x. All right, now I've got x on this side and I've got x on this side. So I can either move this x over here or I can move my negative 5x over there. I can move the negative 5x over here by adding x to both sides, or I can move this x over here by subtracting 1x from both sides. It doesn't matter. You're going to end up at the same answer. So what I'm going to do is I don't like negative numbers, so I'm going to add 5x to both sides. Okay, negative 5x plus 5x on the left side of my equation leaves me with 0. Then on the right side of my equation, I have 10 plus 5x plus x is 6x. Okay. Then what I'm going to do, now that I have 0 is equal to 10 plus 6x, um, I'm going to subtract 10 on the other side. I'm going to subtract 10 from both sides. Now, I don't like negative numbers, but it doesn't seem to be a way around it. But at least my negative is not on my variable, and that's one thing I am trying to avoid. Okay, so now I have negative 10 is equal to 6x. All right, so if I divide both sides by 6, what I'm left with is x is equal to negative 10 over 6. Okay, so if x is equal to negative 10 over 6, I can simplify that. This is an even number over an even number. So I know I can at least divide the top and the bottom by 2. And if I do that, that's negative 5 over 3. Now I can leave it like this. That's an improper fraction that I can no longer, what am I trying to say? Simplify. Or I can change that back into a mixed number. All right. So if I'm going to leave it as an improper fraction just like that. If you were to change it into a mixed number, you would have three threes. 3 over 3 would be 1 unit, and then you'd be left with 2 more thirds. So then you'd be 1 and 2/3 if you really wanted to change it. But otherwise, leaving it like this is fine. And that's the answer. All right. I'm going to work another one for you. All right, we're going to have negative 2 times x plus 2, which is equal to negative 1 minus 3 times 3 plus 2x. Something big and hairy. All right. Something big and hairy. Okay. So, what on earth am I going to do here? I've got to get x by itself on either the left or the right side of this equation. So one of the first things I want to do is see if I can't drop these parentheses, combine any of my like terms together, and then start moving numbers to one side, variables to the other side, and see if I can eventually get that x to be by itself. So in order to do that, I need to drop these parentheses so I can move stuff around. So I'm going to take this negative 2 and I'm going to distribute it into this quantity here. Negative 2 times x gives me negative 2x. Negative 2 times positive 2 gives me negative 4. And that's going to equal negative 1. Now I've got a negative 3 that I'm multiplying by this, so I'm going to distribute that in. Okay? Negative 3 times positive 3 gives me negative 9. Now what I'd like to do is I'm going to combine some like terms. So you see here that I have a negative 1 minus 9. Well, I can combine those two together, and that gives me a negative 10. All right, then I'm have a negative 6x here on this side. And then over here, I cannot combine the 2x and the 4 because those are not like terms. So I've got that right there. All right. Now I am going to get all my x's. What I'm going to do is I'm going to move all my x's to the left side and all the other numbers I can to the right side. Okay, so let's start with the x's. I'm going to move it to the left side. So I'm going to add 6x and add 6x here. Okay. So negative 6x plus 6x there. That goes away. I'm left with just the negative 10 on the right side. On the left side, I'm also adding 6x. So negative 2x plus 6x, that gives me 4x. Then, so I have 4x minus 4 on the left and negative 10 on the right. All right, so now I'm trying to move my numbers without the variable to the right side. So I'm going to add 4 on both sides of my equation. Negative 4 plus 4 on the left gives me 0. 0 plus 4x just gives me 4x. Negative 10 plus 4 gives me negative 6. All right, so even though I have this 4 over here next to the x, notice how now I don't have any addition or subtraction. That's kind of the first thing when we whittle this down, right? We are having x times some number equal to another number. So in this case, negative 6. So in this case, now to get my x by itself, what I'm going to do is I'm going to divide both sides of my equation by 4. Okay? Divide that, and I'm left with x is equal to negative 6 over 4. And now I can simplify this number. The negative 6 over 4, I can simplify. Divide the top and bottom by 2. That gives me negative 3 over 2. All right, I'm not seeing any question marks come through. So I'm assuming everybody got that written down and understands what's going on. So let me work another one like this. That's a little hairy because I think that's helpful. All right, let's do y plus 3y minus 1 equals negative 15 plus 2y. All right. Okay, we have y plus 3 times the quantity y minus 1 is equal to negative 15 plus 2y. All right, so in order to start moving all of my variables to one side, and I like to put them on the left, you don't have to, but that's just what I like to do. Then all the numbers on the right. Um, I could I could subtract 3 times the quantity y minus 1 and put it over here. But I can also drop these parentheses if I go ahead and multiply that 3 through. So that's what I like to do first. Let's take that 3 and let's multiply that through. Okay. So we have y plus 3 times y is 3y. And then 3 times negative 1 is minus 3. And that's equal to negative 15 plus 2y. All right. All right, so now I've got a lot of addition and subtraction, so I can move stuff to the left and right. But I'll notice right away I've got a y and a 3y here. Those are like terms. They have the same variable in the same exponent. So I can combine y and 3y. So 1y plus 3y, that gives me 4y. I'll rewrite everything else. All right, so I want to have my numbers on the right without the variable and my variable, stuff with my variable on the left. So I'm going to subtract 2y from the right side, which means I have to also do that from the left side. And that effectively eliminates all my y's from the right side of the equation. And here on the left, 4y minus 2y is 2y. All right, now I have 2y minus 3 is equal to negative 15. What I can do here is I can add 3 to both sides of my equation. Minus 3 plus 3 goes away. I have 2y. And then here I have negative 15 plus 3. So that gives me negative 12. Now I have my y on one side and numbers on the other. So the only thing I have left is I have something multiplied. I have a number that if I double it, it's equal to negative 12. So the inverse operation here of multiplying is dividing. 2 times y, so I'm going to divide by 2. And if I do that there, I must divide by 2 on the other side. 2 divided by 2 is 1. 1 times y is just y. Negative 12 divided by 2 is negative 6. And y is negative 6. All right.